I want to introduce tonight's speaker, Mike Weber. Mike is a popular returning speaker for the museum, and he has a long history and love of Cornwall. As a child, he collected rock and mineral specimens in and around the waste rock piles, and that led him to a study of geology. He is a 1982 geoscience graduate from Penn State. He worked for 36 years as a geologist and health physicist and manager for the U.S. Nuclear Regulatory Commission and the U.S. Geological Survey. After retiring from federal service, he returned to Cornwall Furnace, where he serves as a guide and researches the history of mining and the geology of Cornwall and similar deposits in Pennsylvania. One of Mike's ongoing research projects is studying the records of the Cornwall division of Bethlehem Steel, which he is turning into a book called Always More Production. You can also be on the lookout for an upcoming article in the Cornwall Ledger, that's the newsletter of the Associates Group, and that will talk about the extraction of gold in Cornwall, which of course is this evening's topic. So please welcome our speaker, Mike Weber.
Good evening. There's gold in them thar hills. The hills I'm referring to are Big Hill, Middle Hill, and Grassy Hill at Cornwall, Pennsylvania, of course. Welcome to this webinar on the mining and production of gold from the Cornwall mines. Cornwall is a famous place in the United States and also abroad as an important iron deposit. In fact, the Cornwall deposit has been identified by geologists as a type of iron formation. But did you know that in addition to iron, miners at Cornwall also produced other valuable metals, including copper, silver, cobalt, and gold? My name's Mike Weber, and as Mike Emery already has introduced me, I appreciate your joining us this evening for the webinar. I also would like to thank the Friends of the Cornwall Iron Furnace for sponsoring this webinar, especially Mike Emery, Cornwall Site Administrator and tonight's host, Karen Viozzi, Volunteer Coordinator, and Kathy Donaldson, the Secretary of the Cornwall Iron Furnace Associates. After a brief introduction to gold, I plan to cover the different types of gold deposits, and then discuss specifics about the Cornwall deposit and the concentration of gold at Cornwall. And this will set the stage for discussing how miners and millers extracted the gold, how much gold was produced, and whether there is any gold in Cornwall today. I plan to leave plenty of time at the end of my presentation to answer your questions and listen to your comments. Gold. The very name and appearance of this precious metal excites us. Very few materials that we encounter in our daily lives has the allure, the luster, the sparkle, and the value of gold. Now, humans have prized gold for thousands of years. Small amounts of gold have been found in Spanish caves that date back to 40,000 years BC. So gold is the earliest metal that humans found attractive and used. Once humans produce gold, they tend to hang on to it. So most of the gold that was ever mined from the earth is still being used today. A total of about 220,000 tons of gold exists today above ground. This amount of gold would fit in a cube about 70 feet on a side and would be worth over $9 trillion. And about 75% of this gold has been mined and circulated just since 1910. Most gold today is used in coins, bars, jewelry, and industrial applications, such as electronics, coatings, and nanoparticle manufacturing. Now, throughout history, gold has been associated with both good and evil. We know about the golden rule, the gold standard, and of course, the gold medal, as we see with our Olympic medalist on the left side of the slide. The wise men presented gold as a gift to the babe in Bethlehem. God directed the Israelites to build the Ark of Covenant out of gold. Now, on the flip side, on the right side of the slide, gold can also be associated with greed and with evil, such as the golden calf built by the Israelites after they escaped Egypt. Humans throughout history have also become obsessed with gold, such as Midas in the search for El Dorado and other similar stories. It was this obsession that prompted the title of our webinar this evening, There's Gold in Them Thar Hills. This oft-repeated phrase is actually a famous misquotation popularized in cartoons like Bugs Bunny and Yosemite Sam. The expression is also featured in Mark Twain's book, The American Claimant. Twain heard the expression from miners heading to California in the gold rush, prompted by the discovery of gold near Sutter's Mill in California in 1848. The miners heard the expression from Dr. Matthew Stephenson, who served as an assayer at the Dahlonega Mint in Dahlonega, Georgia in the 1840s. In 1849, Stephenson tried to persuade a group of miners to stay in Georgia and continue mining gold by stating, "In that ridge lies more gold than man ever dreamt of." Somehow that statement got contorted into "there's gold in them thar hills." At the time, the miners in Georgia were losing interest in mining gold there, the location of the second gold rush in the United States, which lasted from 1828 until the 1840s. This rush in Georgia followed the first gold rush in North Carolina, which began in 1803 and lasted until the 1820s. Now, gold is found in its pure metallic form in a variety of deposits around the world. When most people think of gold in the earth, they think of placer deposits, where the gold exists as nuggets or flakes of gold in sand and gravel. The gold was deposited at the base of flowing streams that deposited the sand and gravel because it's denser than the other sediments. These deposits are mined by gold panning, as well as hydraulic sluicing and similar methods, all of which involve the sediments being washed away, leaving behind the gold flakes and nuggets. Sometimes the source of gold in placer deposits can be traced back to the mother lode, a deposit in quartz that contains wires or flakes of gold. In these hydrothermal vein deposits, hot mineral-rich solutions deposited the gold in rock, typically quartz, like in the Sierra Nevada mountains of California or the Rocky Mountains near such places as Cripple Creek and Leadville, Colorado. The gold at Cornwall exists in neither of these two kinds of deposits, but rather in the third kind called a disseminated deposit. In these deposits, the gold cannot be seen by the naked eye, but is instead in finely dispersed as particles, molecules, or atoms in other minerals. The photo on the bottom of this slide shows a microscopic view of a rock with tiny crystals of minerals like feldspar, magnetite, and biotite. The gold is disseminated throughout the rock. This is the kind of deposit that yields gold at Cornwall. So at Cornwall, the gold primarily is found in the brassy-colored sulfide mineral called chalcopyrite. Chalcopyrite is an important ore of copper, and it consists of iron-copper sulfide. At the molecular level, chalcopyrite is comprised of iron and copper atoms that are bonded to sulfur atoms. In the chalcopyrite at Cornwall, gold and silver atoms substitute for a small percentage of the copper atoms. The gold and silver are finely disseminated within the chalcopyrite itself. Now you can see chalcopyrite disseminated throughout the iron ore at Cornwall. However, you cannot see the gold contained within the chalcopyrite. Sorry, no flakes, wires, nor nuggets of gold at Cornwall. This map shows how the chalcopyrite, or the copper, was distributed in the eastern ore body of Cornwall, which was mined in the underground mine number 4, about 1/2 mile east of the open pit. The map is based on chemical analyses of ore samples collected by miners and geologists from 1929 through 1955. The map depicts the percent of copper found in the iron ore. The greater the amount of copper shown on the map, the greater the concentration of chalcopyrite in the ore. So miners found the highest concentrations of copper in the ore up here near the top of the ore body, close to where the number 4 and the number 5 shafts penetrated through the soil down underground. Most of the ore body contained less than 0.5% of copper. Because the gold substituted for copper in the chalcopyrite, the concentration of gold varied proportionately to the concentration of copper in the ore, albeit at far lower percentages. So we now know that the gold at Cornwall was disseminated within the ore, but just how disseminated was it? I used ore production data from 1966 to give you an idea of how disseminated the gold was at Cornwall. On average, 1 ton of iron ore produced at Cornwall in 1966 yielded about 0.5 ton of the iron mineral magnetite. That same ton of ore yielded about 17 pounds or 0.0085 tons of copper concentrate. Further processing of the copper concentrate yielded the copper, gold, and silver, as well as additional iron. So out of the 17 pounds of copper concentrate, the millers extracted about 23 milligrams of gold, or a very, very small fraction of a ton of gold. You've no doubt heard the expression, a drop in the ocean. This is a good depiction of that expression. In other words, to produce 1 standard bar of gold containing 400 troy ounces, you would need to process almost 550,000 tons of Cornwall iron ore. That is a lot of ore to process to recover a bar of gold. Another way to look at the dissemination is to recognize that Cornwall contains only about 15 times the average abundance of gold across the surface of the earth. Now, a typical gold deposit needs to contain at least 4,000 times the average abundance of gold to make it worth mining. So if that's the case, how could miners at Cornwall recover gold when it's about 400 times less concentrated than it would need to be in order to make the gold worth mining? Aha! The answer to that question lies in the power of concentration. As you see in the graph in the middle of the slide, when mining began at Cornwall, the concentration of iron in the ore was relatively high, in the 60 to 65% range. As mining progressed, the concentration of iron decreased in the ore. The concentration decreased because waste rock became incorporated in the mining of the ore itself, but also because the percentage of the iron mineral magnetite in the ore decreased. Miners could boost the iron concentrations in the ore somewhat by carefully separating out or so-called cobbing the ore from the waste rock. However, the miners could not do much about the concentration of iron in the ore beyond classifying the ores based on their grade or quality. By the 1870s, the concentrations of iron in the ore were too low to be used directly in the charcoal cold blast furnaces like Cornwall furnace without blending the ore with more concentrated ores. The operators of the Cornwall Ore Bank Company, then the miners, consumed the best ore in their own furnaces and sold lower graded ores to their competitors. By the turn of the 20th century, the company decided that they needed to concentrate the iron in the ore to boost it from around 40 to 45% back up to 60% iron. Consequently, the Cornwall Ore Bank Company, along with the North Lebanon furnaces, built and began processing the iron ore at the concentrator plant in Lebanon in 1905. This increase in concentration is seen in the graph by the green line. Had they not operated the concentrator, the concentration of iron would have continued to decline as depicted by the red line in the graph. Bethlehem Steel replaced the first concentrator seen in the upper photo on the right with a new and improved concentrator at Cornwall in 1962, which is the lower photo on the right. So without using the concentrator, or conci as it was known by the locals, to concentrate the iron from the Cornwall, it would not have been feasible for the miners and millers to recover gold or the other metals from the ore. When the concentrator first began operating in 1905, it crushed and concentrated the iron from the ore. Beginning in 1922, Bethlehem Steel began experimenting with using new processes to recover the copper, in addition to the gold and silver. In 1927, Bethlehem Steel added a series of additional processing steps on the back end of the concentrator plant. These steps occurred in the flotation plant and were designed to separate and increase the concentration of copper in the residue that otherwise would have been discarded after the extraction of the iron. On this slide, you can see a simplified diagram, and I'd emphasize simplified, from 1945 of just how the concentrator worked. Don't worry, I'll go through this in some detail so you'll get an idea and an understanding of how this process worked. This diagram is called a flow sheet, and it summarizes the sequence of processing steps used by Bethlehem Steel to concentrate the iron ore and extract the other metals at the concentrator. The flow sheet can be simplified for this presentation into 5 steps, and those 5 steps are highlighted in the yellow circles. In the first step, number 1 in the yellow circle, the ore from Cornwall was fed into a grinder and ground finer to about the consistency of wheat flour. During the winter, the ore would often freeze on its way in the rail cars from Cornwall to Lebanon, so workers at the concentrator had to use jackhammers to break up and feed the ore into the ball grinder where it was ground to a finer degree. The ground or milled ore was then mixed with water and fed into a series of magnetic separators, step number 2. You see those magnetic separators in the picture on the bottom of the slide. In this step, the iron mineral magnetite was attracted to powerful magnets, while the rest of the solution containing the remnants of the ore flowed downstream. Blades close to the rotating drums then scraped the magnetite off the drums to concentrate the iron. In step number 3, the rest of the ore was processed through a series of physical and chemical steps to concentrate the finely ground chalcopyrite that contained the copper. The solution was processed through machines called rake classifiers, thickeners, and flotation cells. Various chemicals, such as pine oil and flocculant agents, were added in this sequence of steps to attract the chalcopyrite to bubbles that floated up to the top of the water. At the end of the cycle in the flotation cells, which you see in the lower photo in this picture, the bubble froth containing the copper concentrate was then skimmed off the surface of the solution, further thickened, and then concentrated using filter processes. And these solids were the copper concentrate that was then sent off-site to smelters in Arizona, New York, Michigan, Canada, and Washington for further processing, including the extraction and concentration of the gold. The flotation plant also concentrated additional iron, like we saw before in step number 2, using the magnetic separators. This iron was then sent on to the sintering plant for final processing. Processing of pyrite concentrate, a different brassy mineral, is shown in step number 4. And that began at Cornwall in the late 1920s, with full-scale production beginning in 1940. The pyrite was valuable because it contained trace amounts of the metal cobalt, ranging from 0.7 to 2% by weight. After the copper was removed in the flotation plant from the sulfide froth, additional processing was used to produce a pyrite concentrate using similar steps, but different chemicals and sequences. Cornwall shipped the pyrite concentrate to Baltimore and to Sparrows Point, Maryland, where the concentrate was roasted and then leached to remove and concentrate the cobalt. Cornwall became an important source of cobalt for use by the nation as an iron alloy in armor plate and armaments, just in time before and during World War II and the Korean conflict. Finally, in step 5 of the simplified process, the solids that remained after they've been stripped of iron, copper, and pyrite, along with a solution that carried them, were discharged into large impoundments. These solutions are called tailings, as seen here in the photograph of the old quarry behind the concentrator plant in Lebanon. Once a year, the millers reprocess the tailings in the quarry through the concentrator plant to recover additional iron, copper, and pyrite. The reprocessing occurred during a 2-week period in the summer months typically, when the rest of the concentrator and the Cornwall Mine suspended production to conduct large maintenance projects. After the tailings were reprocessed, they were disposed of in large tailings impoundments that were located close to the concentrator plant in Lebanon on the north side of Route 72 near the intersection of Maple Street and Jonestown Road in an area referred to as Sand Hill. You can see this large impoundment above the concentrator plant in the photo on the left. After the concentrator relocated to Cornwall in 1962, the millers stopped reprocessing the tailings and sent them directly to a large tailings impoundment located in Cornwall above Rexmont. This tailings impoundment is shown on the photo on the right. Today, you can view the embankment for this tailings impoundment as you're driving on Route 419 just east of Cornwall, but keep your eyes on the road, please. This slide shows one page of Cornwall's monthly report for July 1939. The entire report that month from Cornwall was about 100 pages long and contained lots of detailed information. Each month, Cornwall reported this detail to Bethlehem Steel's corporate office in Bethlehem, Pennsylvania. I included this in our presentation tonight so you can get a sense of how detailed these reports were, and so you see that Cornwall explicitly documented gold, silver, and copper production in these reports. However, after 1940, Cornwall did not resume reporting on gold and silver production until 1966. In the red oval on the left, you see that in July 1939, Cornwall produced about 606,000 pounds of recoverable copper. The green oval on the right highlights the $47,000 of revenue in copper, gold, and silver Cornwall produced that month, including $4,407 of gold credit. Of course, that's not profit because you would have to subtract the operating cost for mining and milling the material. The report indicates, however, that Cornwall was making a lot of money at this time by producing gold, silver, and copper, in addition to Cornwall's main product, iron. This graph shows the estimated amounts of gold and silver produced by Cornwall over the period from 1922, when recovery of those metals began, to 1973, when mining ended at Cornwall. The gold line represents the amount of gold produced in troy ounces each year. The blue line represents the amount of silver produced in troy ounces every year. As you see, the amounts fluctuated considerably over the years. These variations were primarily driven by changes in the amount of iron ore produced, concentrations of copper in the ore, and the recovery levels, or so-called practice, achieved by the flotation plant in the concentrator. So based on these records, I estimate that Cornwall produced over 62,000 troy ounces of gold. Before 1940 and after 1966, monthly records from Cornwall reported exactly how much gold was produced and how much credit Cornwall received from the Bethlehem Steel Corporation for gold, copper, and silver production. Between 1940 and 1966, although the monthly reports continued to provide the amounts of copper concentrate produced, the amounts of gold and silver produced were not explicitly reported. So I used production rates both before 1940 and after 1966 to estimate the production of gold and silver during this interim period based on the amount of copper concentrate produced. Concentrated or metallic gold was not produced at Cornwall nor at Lebanon, so there was never any storage of gold or silver bars at Cornwall. The total gold reported from Cornwall from 1922 until 1973 would have been enough to have made about 155 standard gold bullion bars at 400 troy ounces each. This is a small fraction of the total gold produced in the world. By using the price of gold in the New York market for this period, the total value of the gold produced at Cornwall was on the order of 2.2 million unadjusted dollars. This is not a lot of money compared to the total value of the 100 million tons of iron ore produced at Cornwall. The money did, however, add to the profit margin for the operation of the mines, especially when it was included along with the value of copper, silver, and cobalt. It was, so to speak, the icing on the cake. Still there? Not you, but rather the gold that was not extracted. Cornwall records the extraction of gold beginning in 1922, 185 years after iron mining began at Cornwall in 1737. So what happened to the gold that was mined before gold separation began? Now, before you grab your gold pan and head out to the Furnace Hills, I need to warn you that you will probably not be able to recover the gold in any appreciable amounts. We know that the early ore produced at Cornwall had fewer sulfide minerals because the iron ore was weathered at the surface. The gold that would have previously been present in the surface ores likely dissolved and washed downstream into the creeks, streams, and rivers like the Susquehanna River onto the Atlantic Ocean, where it resides today. Not as flakes, wires, and nuggets, but more likely as microscopic particles, molecules, and atoms. Once the surface ores were consumed and the iron concentrations began to drop, miners avoided or tried to avoid the ores that contained the sulfide minerals. If they could not be avoided, then the miners roasted the ores to reduce the amount of sulfur they contained to make a higher quality cast iron. After the sulfur was driven off by roasting, the gold likely remained in the iron ore, which was then fed into the furnaces. Research performed by the U.S. Geological Survey at nearby Hopewell Furnace found that the most of the copper and gold in the ore became incorporated into the cast iron. A smaller portion ended up in slag produced by the furnaces. If the gold suffered a similar fate at Cornwall, as would be expected, then most of it is distributed around the United States and the world in iron and steel that originated at Cornwall and the other furnaces that were supported by the Cornwall ores. And a lesser amount resides in the slag produced at Cornwall and the other furnaces that use Cornwall ore throughout the 18th, 19th, and early 20th centuries. When the mining ceased in 1973, more than 1 million tons of iron ore remained in the ground at Cornwall, including the open pit and in the number 3 and the number 4 underground mines. However, to produce gold economically from these deposits, you would have to process huge quantities of iron ore and extract the other metals, including iron, copper, silver, and cobalt. Remember that 550,000 tons of iron ore that would have to be processed to make 1 gold bar? It is unlikely that the quantities of ore that remain in the ground could be economically recoverable. In addition to the costs of producing and processing these large quantities of ore, there are the costs of developing the deposits, constructing the mining and milling infrastructure, securing the mineral rights and permits, and other administrative costs. Consequently, I end my presentation with my beginning, stating, "There's gold in them thar hills," and there it will remain for the foreseeable future. Thanks for your attention, the support of the Friends of the Cornwall Furnace, and for our marvelous history here at Cornwall and Pennsylvania. And now I'd be happy to answer any questions that you might have.
Well, thank you very much, Mike. Another great presentation. So I guess we won't see many people with their pans in Furnace Creek over the next few days. So thanks for dissuading that. Right now, I do not have any questions that have come through. So just go ahead and wait for a moment or two. Do you know, Mike, if any gold ever came back? Like, I know in different locations, they'll have commemorative pieces that would be made for like key staff members or anything. Did you ever see any of that being made for Bethlehem Steel Corporation? Or
I
here
know
at any-
that some of the longtime retirees received watches at their retirement celebrations. I don't know if they were gold watches or steel watches,
Right.
but they may have come back for that. I'm not aware of other decorative objects that would have brought the gold back, unless it came back in the form of gold jewelry and other things like that.
Okay. Got a couple of questions that just came in. There are stories of gold in northern Lebanon County, Gold Mine Road. Do you know anything about that?
Not particularly. There was a lot of speculation and exploration that took place, especially as gold was being produced. And just the presence of the Cornwall iron mines in Cornwall attracted a lot of interest by local landowners in trying to pursue similar sized deposits and reap similar economic benefits from their development. Throughout the history of the Commonwealth, Cornwall is by far the largest source and generator of gold and silver, as well as copper. There were some other reported gold finds down in the Philadelphia area in the early 1700s. Gold has also been found in minor quantities in other mines around the Commonwealth. But I'm not aware of any specific gold mining that took place in northern Lebanon County.
Okay. You actually just answered the second question I had here about other sources of gold in the Commonwealth. So thank you very much. Okay. Let me see. I've been involved at the archaeology at Elizabeth Furnace. Have you come across the local sources of iron ore used at Elizabeth Furnace?
Well, it's funny that question comes in because Mike Emery and I have been pursuing that, and that prompted my conduct of additional research to track down where the ore came from that was fed to Elizabeth Furnace. As best I can tell, most of the ore that was used by Elizabeth Furnace came from Cornwall, and that's the channel through which Robert Coleman, one of the early developers of the Iron Dynasty there in Cornwall, became aware of the wealth and made it attractive to him to acquire Cornwall. There are reports that other ores were used. It may have been early on in the operation of Elizabeth Furnace that different ores were mixed to develop a high quality product. But a lot of those iron deposits were more of the bog iron or sedimentary iron, formed differently than the Cornwall deposit. And if they were produced from those deposits, most of those deposits were relatively small and typically existed in a plot on a farmer's land. And once the mine was no longer producing higher quality iron ore, then the miners either allowed the water to fill in and produce a pond, or they rehabilitated the land and used it as a source of farming.
All right. Another question here. It said Water Street in Lebanon has a water channel through that was part of the processing, talking about the concentrator plant. Also along Route 72, the old timers called it the Schmutzi. Is that the tailing impoundment?
Yes, the Schmutzi is comes from the German word Schmutz, which is dirt, not like soil, but just soot. And because it was ground so finely, the ore, when it was processed into the tailings, looked like soot. So that's where the derivation of that term comes from. I am aware, they had to pump the tailings from the concentrator plant out to the tailings impoundment. And they did that a number of ways. They used what was called a tailings launder. That was typically a wooden lined box that was like a sluice, and it transported the tailings to the impoundment. Later in the operation of the concentrator, they actually then piped that to reduce environmental contamination and pollution. So I think that's all tied up into how the tailings were produced and sent out to the tailings impoundment.
All right, another question here, Mike. How deep did the tunnels finally reach at the Cornwall mines?
So the mine drifts in the number 3 mine, which was constructed below the open pit, went down about 700 feet below the land surface. And the deepest drifts that were used to produce iron ore from the number 4 mine, which was the ore deposit that I showed the map of and was about a half-mile east of the main deposit mined by the open pit, those drifts went down to about 1,200 feet below the land surface.
Okay. When was it realized that gold was present in the iron ore?
So back in the late 1800s, as part of the exploration of the ore deposit at Cornwall, they conducted much more refined analyses of the ore samples. And it was at that time that they looked for additional elements besides the ones that were most prevalent. The thing that caused the most difficulty in processing the iron ore at Cornwall was the presence of silica. So we know from about 1885, 1887 or so, they were measuring silica in the ore deposits. But it was later in the late 1800s, early 1900s that they actually started looking for other elements besides the more common ones. And that's when they identified the presence of gold. Of course, they had to process, again, through the concentrator plant. That concentrator plant only started operating in 1905, and then they only added on the features to the process to recover the copper concentrate in 1922. So you could say they knew there was gold there, they just didn't know how to get it out economically. And then in 1922, they figured that out. And so in addition to getting the gold and silver, they also got large quantities of copper from the ore.
All right, another question. Can you explain the purpose of using a sulfide bath in the concentration process after the magnetite attraction step?
So the sulfide refers to the chalcopyrite and the pyrite. So that was a preparatory step to the flotation process to recover. I'm going back to the flow sheet now. So I think the person may have been referring to the sulfides froth. And there's also a copper froth. Yes, so that sulfides froth, that's the beginning of the flotation process. And that's where you've separated out a lot of the magnetic iron, and now you want to concentrate the sulfides, both the chalcopyrite and the pyrite. And so that's the feed stream that then goes into the 2 subsequent processes to recover the chalcopyrite and concentrate it, as well as recover the pyrite and concentrate the pyrite concentrates.
Okay. Another question. Is Cornwall... All right, Mike. Looks like you had a question for the dog.
I'm back. I think my dog wanted to ask a question.
All right. Is Cornwall still considered a major iron ore deposit? For instance, Spring Hill Acres was part of Bethlehem Mines, but never developed.
I would say that Cornwall is no longer considered an iron deposit, but interestingly, well into the 1980s, Cornwall remained a strategic deposit for the United States for cobalt. Okay, back with you, sorry.
Not a problem.
That's the dog that I used to protect my gold.
There you go. Roughly how many mineral types total are known to have been found in Cornwall?
That's also an interesting question. I would say in rough numbers, it's about 100. Depending on which author you read, I've seen estimates from 85 to slightly over 100. What's interesting is, of course, as the ore was mined, the assemblage of minerals changed. And so minerals that were found rather early on might not have existed when subsequent mineralogists and geologists explored the ore body. And so what I'm saying is some geologists that came along later in the years of the 236 years that the mine operated started to question whether the early mineralogists really did discover some of the minerals that were reported to have been located at Cornwall.
Okay. Another question. Was the recoverable silver found in the quartz deposits, much like the Peckway silver mines in Lancaster County, or the iron deposits themselves?
So the silver and the gold were both found in the chalcopyrite at Cornwall. So that would have meant that they were found in the ore deposit, the iron ore deposit itself, and not in quartz deposits. The Peckway silver mine and Peckway silver deposits, that's more typical of that second type of ore body that I described for gold, the hydrothermal vein deposits.
Okay. Question, and I think this is referring to the height of Big Hill or the depth of the ore body. And the question was, when the iron ore deposit was first found in the 18th century, how high was it?
Okay, so the iron ore was found at the surface of Big Hill and also at the surface of Middle Hill and Grassy Hill. Now, of those three hills, Big Hill was the tallest, and there's various estimates of the height of Big Hill because they really didn't have the sophisticated means of mapping the land surface topography before the miners had already gouged out the middle of Big Hill. But early accounts talk about Big Hill being in the vicinity of 400 to 410 feet above sea level. And then Middle Hill was less, like around 360 feet above mean sea level. And Grassy Hill was also less than Middle Hill. So I think I answered the question.
Yes. Now I'm going to combine a couple of people's questions here, but I think they're all asking roughly the same thing. Were the waste materials from an earlier period ever reworked to try to get other, material out of it, like more iron, gold, or anything else, particularly the slag?
So we don't have, as far as I know, any records that the slag from the furnace at Cornwall, the charcoal furnace, or the other nearby furnaces were ever reprocessed to recover the valuable metals. We do know that the slag from, for example, the Bird Coleman furnace was crushed and used as aggregate for railroad ballast and for road aggregate. So that was just a convenient source of rock, basically. The tailings, as I mentioned in my talk, that were produced by the concentrator in Lebanon were stored in the freshwater supply for the concentrator plant in the old quarry, or the so-called old quarry. And on an annual basis, those tailings were reprocessed, fed back into the flotation plant to recover additional iron, copper, and pyrite. And that went on from the 1930s, the late 30s, until the old concentrator closed down in Lebanon in 1962.
Okay. Another question, is it possible to visit the sites of mining in Cornwall?
All the mines reside on private property. So your best bet to see the mines are to drive through Cornwall. Boyd Street itself gives a great view of not only the open pit to the west of Boyd Street, but also Big Hill to the east of Boyd Street. And of course, most of the early mining occurred in Big Hill, and the miners gouged the middle of Big Hill out because that's where the iron ore was located. And then after Big Hill was essentially depleted by about 1920 or so, then the primary focus of mining shifted over to the open pit, which was beneath Middle Hill and Grassy Hill. And you can get very great views of all those mining activities, the surface mining activities from Boyd Street.
All right, I'm going to paraphrase this next one a little bit. Does iron today, as it's produced, contain gold like it did at Cornwall, or is that usually something that's now taken out?
So it's like many things. In some locations, depending on how the iron ore was deposited, you may find elevated levels of gold as well as other precious metals. That's probably the most straightforward answer I can provide.
Okay, not a problem.
But I would not assume that all iron ore deposits have elevated concentrations of gold.
Okay, so
it
that
really depends on how the deposit formed. And
okay. This is a question about the ore body here. I know, and we've talked about this a little bit, Mike. Could you just kind of explain a little bit about the ore body, not how it's formed, but the location, but also the fact that it was accessed by more than one location?
Sure. So there's actually two deposits of iron ore at Cornwall. The main deposit and the deposit that was mined first, beginning in 1737, extended for about a mile distance beneath Big Hill, Middle Hill, and Grassy Hill. At places, it was up to a couple 100 feet wide, and it extended vertically down, especially beneath Middle Hill and Grassy Hill, about 700 feet. Now, the miners who were mining that ore body couldn't get all of the ore out of the open pit because to do so, because of how deep the ore extended, they would have had to greatly expand the size of the pit. And so they decided in the 1916-1920 time period that it would be best to mine the remainder of that first ore body by using an underground method. And that's what gave rise to the number 3 mine, where they built a shaft down the north face of the open pit and the western end of the open pit.
100 years ago this year, correct?
100 years ago this year, exactly right. Throwback Thursday.
Yes, Throwback Thursdays.
And so that was the number 3 mine, and that extended into the ore body another 300 feet. So that's the 700 feet of extent, vertical extent of that ore body. The second ore body was smaller. It was found by geologists in 1919 and using a dip needle survey. And that ore body extended vertically from 150 feet below the surface down to about 1,200 feet below the surface. And as I said in my talk, ore was left behind in all of the mines at Cornwall. The open pit, there was ore remaining, and there was also ore remaining in the number 3 mine and the number 4 mines when they closed down after they flooded after Hurricane or Tropical Storm Agnes.
Okay, and there's just one more, a final question, and this one here we may not know the answer for, but I think it's worth discussing. What mineral specifically was Peter Grubb looking for or stumbled upon when he tested the soil and set it up his forge prior to the iron furnace existing?
We don't know, but we do know that Grubb's family back in Wales had been involved in iron mining and processing even before the Grubbs came to the colonies, and then Peter was born. So from that, I speculate that Peter would have been aware of good quality iron ore, whether that was magnetite, like was found at Cornwall, or hematite, which was also found in the upper part of the Grassy Hill deposit at Cornwall, or limonite. All 3 of those are principal sources of iron around the world, and were found in Wales. And so I suspect that Peter was looking for one or all 3 of those iron minerals when he was out exploring the great wilds here in Lebanon County, or what would become Lebanon County.
Well, all right. Well, that I believe concludes our question and answer session. So thank you very much for joining us for this lecture. I especially want to thank Mike Weber for his presentation, and for Kathy Donaldson for helping us to organize this virtual talk. I also want to thank the Friends of the Cornwall Iron Furnace who sponsored this program. If you or your business would like to sponsor a future lecture, please contact the site for further information. And of course, donations are gladly accepted. Please join us for our next lecture on Tuesday, July 13th, which will be on Lebanon County Schools, and that will be given by Jared and Michael Blouch. Just a reminder that the museum is now open. Our first day of operation was on Friday, April 30th. Our hours of operation were open on Fridays and Saturdays from 9 until 4, and on Sundays from noon till 4. And you can check out our website or Facebook page for details and tour information. It is best to call ahead if you'd like a tour, and of course the site number 717-272-9711. So thank you very much, everyone, and please be safe, and thanks for attending.